Hey everybody, and welcome to Let's Look at Human Resource Machine. This is a game from Tomorrow Corporation, who is well known for World of Goo, and also, I think, fairly well known for Little Inferno. Human Resource Machine takes that similar kind of aesthetic from both of those games, obviously, but predominantly I get a lot of Little Inferno, especially from the character designs here. But it is a little bit of a different game. Little Inferno was kind of an ambient puzzle game with environmental overtones and some cool mechanics that didn't really resonate with me, but a lot of people were like, you're sleeping on this game, it's really good. Human Resource Machine is actually like a puzzle game that simulates almost programming logic, and I've been learning programming myself since about April, so I guess almost coming up on 1 year right now, and I slept on this game when it came out in October. It was one of the games that was on my list to cover and be like, okay, do your due diligence, go back, and I'm really glad I did. I bought a copy for myself off Steam. It's $10 US. I guess that would probably make it like 12 Canadian or 11 Canadian right now. I can't remember, but and I've been having a lot of fun with it, and it's a really innovative and fun kind of puzzle game, actually, that I think is definitely going to be niche, but if you missed out on it last year and didn't see any coverage for it, hopefully this can supplement you. I'm going to start up a new game, and we'll play as this dude here. Like a lot of Tomorrow Corporation's games, and by a lot, I mean the other two that I've played at least, there is a little bit of a story that kind of wraps itself around it. Some of it is told ambiently by the way your character's appearance changes. Some of it is told a little bit more explicitly, but not really explicitly, through things like cutscenes. And I wanted to start a new one here, just to show you, basically from the ground up, how this works. So, I'm not learning assembly, but I've been told that the programming logic in Human Resource Machine resembles assembly the closest. But if you've learned any sort of programming, you can apply the puzzle-solving skills or problem-solving skills from your learning to actually do this, but at the same time, I think it does a pretty good job of making it accessible for beginners and complete neophytes alike. You look like an excellent instruction follower. Your first job will appear over there on the right side in a moment. Remember, you can always ask me for help. So basically, all of our tasks in Human Resource Machine involve taking stuff from the inbox, manipulating it, and putting it in the outbox. So, you know, much like programming is just manipulating, storing, you know, changing data, and then pushing it somewhere oftentimes, this is pretty much exactly what we're doing here. So we basically visually just drag and drop our program here, or our code, if you will. This is basically our code window, or our editor. So we got two commands right now, but it'll get bigger very fast, and I probably won't take too much time to explain exactly what's going on all the time for the banal minutia anyway. But we got two commands. Inbox, grab something from the inbox, boom. And then our program failed because management expected a total of 3 items, not 0, in order to get the correct solution. We need to move everything to the outbox. So we'll stop that, and then we'll put an outbox. Outbox takes whatever we're holding and puts it in the outbox. So, if we speed it up a little bit here, we grab something from the inbox, put it in the outbox, but wait, we need 3 items, not just 1. So then we do inbox, outbox, inbox, outbox, inbox, outbox. And I know what people are going to say. Wouldn't it be just simpler if you had some kind of loop there to handle it? Oh, don't worry. We'll get there, and we'll get there very quickly. It is a game that, in terms of its complexity, ramps up very quickly, and also does a good job. Oh, the volume may be a little loud here. Let me just crank that volume down a little bit. I didn't expect the cheers to be so uproarious. Hopefully that's a little better there. Okay. There's no getting around it. We have to go through, you know, all of these to get further. But eventually we start to get to the point where we're optimizing in order to get the smallest program possible, like the fewest lines of code, and also the fewest cycles that the program actually takes to finish. Sounds boring? Maybe not the game for you. Sounds exciting? Solving a program concept or programming concept in kind of the confines of a game with a visual language? You're gonna like this. So here's our loop. Basically, instead of doing inbox, outbox ad nauseum, we just do inbox, outbox, then we put a jump, and it jumps back to the start. So basically, this is like a go-to statement, and it turns this whole thing into like a while loop, or a for each loop, technically. So now, for every single thing in the inbox, I can crank it up a little faster here. We will put it in the outbox, and it will be completed. This is pretty much where the game is just tutorializing things. We get introduced to new code, or new commands very, very quickly. The big thing that we get introduced to in year 3 here, and notice our character's starting to maybe get a little older there, is that we actually have copy from and copy to. So we can actually copy to the floor and copy from the floor in order to store objects and then grab them later. And this is a little bit like creating a local variable and putting a value in there. So ignore the inbox for now. This is our program spec. And just send the following 3 letters to the outbox. B-U-G. The facilities management staff has placed some items over there on the carpet for you. If only there were a way you could pick them up. If we just need to do B-U-G, we'll copy from 4 take it to the outbox. Then copy from 0, take it to the outbox. And then copy from 3 and take it to the outbox. And I'll crank up the speed of it here so you can see it work, but hopefully you can see the steps there and you can understand how it works. We could have also done UBG or, you know, BUG in the reverse order if we wanted to. But for now, it seemed to make sense to just do it the way it was told. Maybe I should have started halfway through, but I promise it gets a little bit more complicated soon. Like, some of the puzzles that we'll see closer to the end of this get very, very complicated. They're a little easier if you've already seen them, you know, in programming before. You're like, okay, that's just a while loop. How do I write a while loop in, you know, the basic graphical language that's going on here? How do I multiply something by itself in the graphical language that we've got going on here without just being able to say, hey, take this and add it to itself, you know, as many times as, I mean, basically it's another while loop. Anyway, grab the first 2 things from the inbox and drop them into the outbox in reverse order. Repeat until the inbox is empty. Here's where things get slightly trickier. So we'll go to our inbox. By the way, this button right here is basically like a step through. So this allows us to see what the next line of our program will do. So the next one is inbox. We'll grab something from the inbox. Then we want to copy that to 0. And if we, again, step through it, we grab it, we put it in 0. We're still holding it, though. What we'll do after that is go back to the inbox, copy that to 1. And you're probably following along pretty simply here, but just in case you're not, we might as well. He'll throw that out because he's grabbing something else from the inbox, puts it in there. Now we need to deliver them to the outbox in reverse order. So what we should do is just take the existing one we have, go to the outbox, and then copy from 0 and take that to the outbox as well. And then, of course, surround the whole thing in a jump. Very, like, intuitive design here. I can't speak, like, if you have no knowledge of programming, if it's easy to wrap your head around, but the way they introduce it, and you're only starting with really 5 commands, and they give you something simple, like take this and then put it over here, I think it does a pretty good job of easing you into it. It's definitely not like a programming teaching tool from a syntactical sense, like you don't actually learn how to write code, but you do kind of learn some very simple programming concepts that are kind of taught in an interesting way, and it reinforces that knowledge as well. But it's not really an educational tool, it's kind of just a really neat spin on a puzzle game. So you look at this here, and we've got our speed cranked up a little bit. This will allow us to deposit them in reverse order, 2 at a time. So each pair will be deposited in reverse order. But you may notice that there's definitely a way that we could optimize this program a little bit. One thing that we could do here, and this is half the fun of the game as well, one thing we could do here is just not copy into 1, and then the program should still run perfectly, but it saves an extra step. And later on, we will be rewarded for doing optimizations like that, which is a really neat way to handle puzzles as well. So we got coffee time now, which is a cutscene, and I'll show it to you to be representative of the kind of cutscenes you see throughout the game. But Tomorrow Corporation, I feel like they have... Again, I didn't finish Little Inferno, but I did finish World of Goo, although it was like 6 years ago at this point. They have kind of this vibe or theme that they have of, like, you know, corporate oppression and also inevitable doom and gloom, maybe with some environmental aspects around it as well. And it's all kind of told oftentimes through this like sepia tone that almost looks like it's from Angela Anaconda or something like that. You're either for that or you're kind of milquetoast on it. Most of the time I found myself kind of milquetoast on it, but I really like the mechanics. So after this, things start to split, and also we can get into some more complicated puzzles. All right. I'm just skipping through the dialogue because I guess I'm too mechanics focused. For each of the 2 things in the inbox, add them together and put the result in the outbox. Okay, so we need to grab 2 things, add them, and put the result in the outbox. This gives us the add command. So we'll grab something from the inbox. We should probably copy it to 0. Grab the second thing from the inbox, add 0 to it, and then take it to the outbox. Now let's just see if that works at a glance so we can step through it here. We grab an 8, copy the 8, throw it away. Grab the 9, which is the second thing, add it to the 8, we got 17, we carry it to the outbox, and then the program will fail because there's not enough stuff in there. So all we need at the end here is another jump, and then we can crank this through, and it should run really, really quickly. Now, even though this is very simple right now, I'm sure some people are like, this is way too easy. It's very satisfying when you have a difficult program to watch it run through, like, super, super quickly. and like try to optimize it to make it work. But once it actually works and it's getting the right result every time, there's almost like a little bit of like a Factorio satisfaction, or an Infinifactory kind of satisfaction of that, or a Space Chem kind of satisfaction of that, of like, I built this generator that actually does what it's asked. And there's a really inherent kind of sense of accomplishment for that. All right, so now we're in the optional areas, which show up at some points for basically harder puzzles that are optional in terms of progress throughout the game. Not if you don't have to do these to actually complete the game, but they are nice if you've got a little bit more of a fundamental programming background, I guess, or foundation. For each thing in the inbox, triple it and outbox the result. Self-improvement tip, where are we going with this? Please leave the high-level decisions to management. Basically, what they're teaching you here is that the game will value optimization through these puzzles. For each thing in the inbox, triple it, and then outbox the result. So we can maybe think of this as like, let's go to the inbox, copy to 0, add 0, add 0. That'll triple it because we're adding it to itself twice. Take it to the outbox, and just jump back. Now let's see if this works. We grab a 2, this should become 6. 4, 6, carry it to the outbox, go back. And then the real test here, because this is a fairly easy one, will be to see if we did it in the fewest number of lines to hit the requirements and the fewest number of cycles. So our size challenge, use up to 6 commands, we use 6. We might be able to do it even faster than that. Do it in 24 cycles or 24 steps or less. We did it in 24 steps or less. I don't know if we could make it any faster, actually. Maybe not with these commands, but another thing you could do, I guess, is pick it up, copy to 0, sorry, copy to 1, and then add this, and then take it through, but that doesn't really, that's one extra step, I think. Also notice that this does a good job of testing the bounds of a program. It's kind of a dorky thing to be excited about, I guess, but they give you an expected value, then a negative value, then a high value, and then a 0. Like, it tests some of the limits of your actual code, which is cool. Let's just complete this one again, and then move on to the next one, because I want to show you the third one in this string of optional ones, and then maybe I'll go back to my other save file and show some later puzzles in the game. But definitely by now, you should know if this is the kind of game that you're interested in, and I'll show you. It goes pretty deep up here. This is the end of the program, but in my actual game, I think I'm only on countdown right now, and I got stuck there for a little while. So this is kind of where I went like, all right, let's cool it for now, and give my brain a rest and try to solve that problem while eating a bowl of cereal or something. But each one of the puzzles maybe take between 2 and 5 minutes, but it depends how kind of well versed in the concepts you are, I guess, before you get into. So I wouldn't necessarily expect this to be a 10-hour-long game, 8-hour-long game. Thinking probably more, a few hours, 3, 4, 5, 6, somewhere in there. But part of the satisfaction as well is as you get into these more complicated puzzles, do you actually care about finding economical and efficient solutions? And if you don't, it'll be a little bit worth less for you, or less long, I guess, for you. But if you are the kind of person who's interested in stuff like that, and if you're interested in the game for its kind of analogs to programming, I could understand that you probably would be. At least I've found myself interested in it. Then you might get a little bit more out of it. There's kind of a self-improvement level here. So this one, for each thing in the inbox, multiply it by 8 and put the result in the outbox. Using a bunch of add commands is easy but wasteful. Can you do it using only 3 add commands? Management is watching. So we need to turn 6 into 48. Let's try doing this with the step-by-step function. Ooh, baby. What does it really mean to multiply something by 8? To me, that means multiplying it by 2, and then by 2, and then by 2, because 2 to the power of 3 is 8, right? So let's say this number was 2. If we pick up a 2, well, let's start with 6. What's 6 times 8? 48, right? We pick up a 6. We multiply it by 2, that makes it 12. We multiply 12 by 2, that makes 24. We multiply it by 24, that makes 48. So instead of thinking like, oh my god, with addition, how are we gonna make a multiple of 8 out of 6 here, or out of any number we get? Instead, you gotta think of like, how many doublings is that? In this situation, at least, not in every single one. The next one is gonna be much tougher. So we'll get inbox, and then we'll copy it to here. And then we're going to want to add it to itself to double it once. So that'll be our first doubling. Hit the button, put it down, add it together. Sweets. Now for, I guess, ease of use, we could just overwrite 0 and then add 0. And then that should give us 24. Well, not 24. This time it'll give us 20, and then it stops. And then we want to get it, well, this one will go to 48 again, which is good. Because they give you different values every time. Copy to 0, add to 0, and then outbox. And then theoretically this should just loop, but let's go through it slowly so we can see. 6 should be 48. 6 plus 6, 12 plus 12. 24 plus 24 gives us 48. We go back to the outbox. Now, kind of another moment of truth. Does it work with a negative number? This should be negative 16. We get negative 4. Negative 4 plus negative 4 is negative 8. Negative 8 plus negative 8 is negative 16. It gets delivered. We've already done a 6, so we can probably realistically assume that a 5 is going to work. 5 needs to become 40, which it obviously is here. And at this point, you can probably see the writing on the wall that this will actually work. The question will be, is this the most efficient way that we can do it with the commands available to us? And the answer is maybe not, but it's probably the most... it's probably efficient enough to qualify. I think, at least. Without having a more stratified ability to write like a for each loop or a while loop, I think this is pretty much the best we can do. Now, this is a challenge that actually I had to think about for a little while. This is the Tetra compiler. For each thing in the inbox, multiply it by 40 and put the result in the outbox. And I was like, oh my god. What does it mean to multiply something by 40? And I thought about it for a while, and I don't expect you watching this for entertainment to come up with the answer in, 15 seconds. But if you do, that's awesome. But let me give you a little hint here. We got 5 spaces on the ground. 0, 1, 2, 3, 4. Why is it not 1, 2, 3, 4, 5? Oh, because arrays in programming are usually 0 indexed. The first value in the array is at position 0. It's got a little programming stuff all throughout it. Well, this is a surprise, huh? But we've already learned how to multiply something by 8. If we multiply something by 8 and then add it to itself 5 times, that's the same as multiplying something by 40. For example, 3 times 8, which we already know how to do, is 24. 24 plus 24 plus 24 plus 24 plus 24, 120. 3 times 40, 120. So basically, all we have to do is do exactly the same thing we did last time. We're going to pick up the inbox, copy it to 0, add it to itself, copy it... Okay, I got confused for a second. It can happen. Copy it to 0 again, add it to itself, copy from... These should be copy from, not copy to. Wait a minute, no, I've got it all wrong. Copy to 0. It's easy to get lost here, but the visual programming language does a good job of making it work anyway. Copy to. So we take a 3. Have I done this right? Let's just do it quickly and see. 3 should equal 24. All right, I'm not a complete idiot. That works right. Then we want to take that 24, copy it to 0, copy it to 1. No, we don't actually have to do that. We could just add it 5 times if we wanted to. Copy it to 0. This is different than I did it last time. 1, 2, 3, 4, 5. Now, oh god, this is wrong. I think I've lost myself, so I'm not saying it's complicated, but the way I've explained it, I may have lost you as well. Don't worry about it. What's 5 times 40? Should be 200. Let's see if we do this, team. 5 plus 5 is 10. 10 plus 10 is 20. 20 plus 20 is 40. 40. Did I do it even with my own ignorance? No, I went one further than I needed to. Okay, that's fine. At least we could visually see that easily. Then you're going to take it to the outbox, and then you're going to jump, and then you're going to do it like that. All right. Let's run through this quickly. What's 7 times 40? 280. Good lord, it works. And isn't it satisfying as you watch those numbers actually become what you want them to be? 5, of course, times 40 is 200. This program is going to take like 200 steps to actually complete. It's probably not that efficient, but it's actually going to get the job done. Oh, we did it right on time, too. See, the way that I did this last time was a little bit different, and this is cool that we can actually see. Like, in my head, I was like, oh, that was cumbersome. But it actually ended up being about as elegant as it needed to be in order to get the job done. What we could have done instead of adding it to itself over and over, we could have copied it, which is what I did last time, and I actually didn't get the bonus for it. We might as well just show that off to see how this is more efficient. Remember, we were right on the borderlines last time. I think we only need to do it for 4, and then you would add 0. This might be slightly off, but we'll see pretty quickly. And you're going to add it to all the boxes that you've copied it to. So 7 should become 280. It does work, but you see that it's actually like 2 extra steps here to do it this way. Man, looking at this little guy go just feels so good. Alright, so that is going to do it, but it's probably going to be less efficient and also slower. Yeah, see? So it's neat how you can actually optimize that stuff. Let's go back to the... Okay, I'll tell you what. Let's finish the puzzle here and then go back to the elevator. I'm not sure if exit game takes us back to the main menu or actually just quits the entire thing altogether. So you can probably tell by now I'm having a really fun time with this. Most of the time when I play puzzle games, I'm kind of like, I'm sorry, I'm bad, I apologize, I'm an idiot, solutions should come easier to me. On this one, I'm like, this is a puzzle game that for the first time in forever actually speaks to me. And sometimes I play, even like a good puzzle game, I play it and I'm like, hey, I like this, but there's no way I'm going to spend any more time playing it. It's like a cool idea, but I can't see myself putting 4 or 5 hours into it. I could definitely see myself finishing Human Resource Machine. Whether or not I actually will, we'll find out. But let's show off maybe one more difficult puzzle, and then we'll finish this off. Why don't we start with something that I can probably remember how to do. Let's go with Equalization Room. So this is our 13th puzzle in the game. Just get rid of the code here so we can solve it ourselves. So now we get some new codes. We get subtract. We also get jump if 0. Basically, this is just like, if it's 0, jump to this line. Get 2 things from the inbox. If they are equal, put one of them in the outbox. Discard non-equal pairs. Repeat. We also have comments now, so we can throw in a comment here and be like, hello. It's weird, I use the mouse with my right hand, but I'm left-handed, so my handwriting with this stuff is really bad. Comments, of course, very useful. We can also leave comments on the ground, but not until we get a little later. This basically it lets you label objects so you remember what they do. So, we need to break this puzzle down into some smaller increments. Get 2 things from the inbox. Easiest thing in the world. Inbox, copy to 0, and then we can do inbox, copy to... Well, we don't even have to copy to. We've gotten 2 things from the inbox now. One of them is stored here. If they are equal, put one of them in the outbox. Okay, how do you discover if 2 things are equal? If I had a number x and a number y, how would I tell if they were equal? Well, you just subtract one from the other, and if it's 0, then they have to be equal. So we'll just, let's leave some comments here. Right here we'll say, oh man. I kind of wish you could type, but wouldn't that make it maybe a little bit too much like actual programming? They got to keep like some semblance of tactfulness here. Got... Oh my god. 2 X's, basically. Hey, these are my comments. As long as I know what they say, it's the only thing that matters. No one else is going to be maintaining this software environment. Okay, after we got the 2 X's, what do we do? We'll subtract, we're holding the second one, remember. We'll subtract the first one from the second one. Then, if we're holding a 0, we're gonna copy the one that we had, because we've already lost the other one during the subtraction, and take it to the outbox. If it's not 0, what do we do then? We will just go back to the start of the program, right? We get into some kind of like nested loops or switch statements here. So let's walk through this step by step. First one should resolve properly. We grab one item from the inbox. We put it down. We throw it away. We grab the second item, and now we got 2 X's. We subtract the first item from the second item. We have a 0. We don't want to put a 0 in the inbox, though. We want to put one of the numbers in the inbox. So we jump to the jump point, copy from 0, which will give us our original number, and then take that to the outbox. Sweet. And then the only thing that we need to do, I think, is take this to the top. Now let's just see if we actually, if an unequal pair will resolve it. We grab the 2, put the 2 down, throw it away. Grab the 8. 8 minus 2 is not 0, so you will not jump. Instead, you'll jump here, right back to the start of the program. And you'll start the whole thing all over again. So I believe that this should actually work. Let's put it on like quarter, or slightly faster speed. Unequal pair gets discarded. Equal pair gets dropped in. Unequal pair gets discarded. Equal pair gets dropped in. Beautiful, we've made it happen. How about efficiency? We took one too many steps? Okay, there's one thing we can do to make this work. One too many steps. Certainly it's not the comment. I will admit the jumps look a little bit, like, unnecessary. Like, this extra jump here seems like it shouldn't exist. What if instead of jumping back, you just jump to here? And that way you're... No, you'll still copy from 0 and then take it to the outbox then. Oh, now I've done it. Alright, well, whatever. Let's just finish it off again. I hope I didn't mess it up. Yeah, it looks like it'll still work. Alright. Well, I think it's pretty clear that I'm having a lot of fun with Human Resource Machine. I'll work on how to optimize that one later. I'm having a ton of fun with the game. It's a puzzle game that I can see myself finishing, which is pretty much the highest praise that I can put on a puzzle game, honestly. It's relatively cheap, it's a lot of fun, and if you're at all interested in the logic of programming and the puzzle solving that is inherent in programming, this is a really cool way to kind of make it fun. But I mean, I would argue that solving problems in programming is already pretty fun, but that's, your mileage may vary. But it's kind of a cool way to do it, and maybe a nice introduction to some programming concepts, you know, like optimizing algorithms and stuff like that, but that's maybe getting a little bit too heady about it. At its core, it's actually just a fun puzzle game that happens to relate to programming. Maybe it's something you geek out over a little bit more if you're currently learning programming, or if you have an interest in it that's long-standing. I think you could find yourself having a lot of fun here. Apart from that, your mileage may vary, but I'm having a great time with it, and I'd go so far as to say that it's one of the best puzzle games that I've played in recent memory, without a doubt. So I would definitely recommend Human Resource Machine wholeheartedly if you like what you see. As always, there will be a link in the video description below to pick it up on Steam if you're interested, and if you are, you can click it. Of course, if you enjoyed the episode, click the like button. It helps out a great deal, and of course, subscribe if you want to see more in the future. For now, thanks for watching, and I'll see you next time.